Hello, in this video, I'm going to explain how to use stepwise linear regression approach to semi-automate multiple linear regression model building process. First of all, why do we need this? Well, number one is if we have increasing number of increasing number of independent variables in our multiple linear regression. What happens here is it becomes computationally very difficult to select which combination of independent variables to include in a model. Yes, we can start with all of them, but sometimes, well, if you have like hundreds of thousands of different independent variables, it might be also computationally very expensive to include all of them into your model and then start cutting them down um, based on the significance of individual independent variables based on their p-values, right? So it is a tedious process. Can we automate it? Not fully, but yes, we can do much better. And that's why stepwise linear multiple regression approach comes into play, just to give you an indication of how much it can get, how quickly it can get complex. If you assume that you have 10 variables, independent variables, and you have potentially 2 to the power of 10, 1024 models that you have to go through, right? Of course, you don't have to go through each one, but technically you have this many alternatives. Imagine that you have, instead of 10, like hundreds of thousands of different independent variables in your model. Well, we can semi-automate it by using step AIC function in R, right? So, but let's first take a look at, let me clear this. Let's first take a look at the general introduction into stepwise linear regression. Stepwise linear regression, it approaches the model from two different perspectives, actually three, but two main different perspectives. When you implement forward stepwise linear regression, what you do is you start with a model having no independent variables and trying to successively adding one at a time to see how much you can improve the R square and just the R square of the model. In the backward selection, you start with all independent variables and then delete one at a time to see which one is going to result in the best approach. So the approach that I showed you in the previous video was actually a backward selection model, right? We start with all independent variables and we let our philosophy, our model building approach, to guide us through the best ultimate multiple linear regression model, right? And there's a general or both direction type of stepwise linear approach, linear regression approach. And in this version, it is using a hybrid of backward and forward selection. So you don't really need to know, how it works because it is already optimized for you. Um, but the key indicator here is to be aware of. It's a very important information to be aware of. So each one of these options might result in a different model, okay, because of the way that they work. And it is always suggested that you should check Vif values for multicollinear, detecting multicollinearity at the very end of the stepwise linear regression. So how do we do this in R? Again, I'm working on multiple linear regression part 2 R file. If you go there, the step AIC function can be found in the mass data, the mass package. I haven't installed this yet, so let's go ahead and run this line. We first have to install this package. It's saying that it's installing the mass package. It's done. Yours might be taking a little bit longer, depending on the dependencies that you already have. And let's load this mass library. It is loaded. Now we are ready to use the step AIC function. Let's cut this help and then paste it here to see what step AIC does give us, right? So it is a function in R and it takes the linear model object here. So we already built a linear model object, right? So we previously built LM5 and this has all independent variables into it, right? All five. We start with all independent variables and then we cut it down, one at a time. And what we are going to do in this case, we are going to feed this LM5, which is the multiple linear regression model that has all the independent variables, into step AIC function. And then we are going to let step AIC do the work for us. We are not going to manually look at the p-values and then try to decide which one should leave, and then rerun the model. All we have to do is to do after step AIC is done, we have to check out the VIF values, okay? So you can take a look at this help and then see, what we need to do. There is one other important criteria here that you have to specify. It is the direction. As I said, you can have forward, backward, or both directions. So I'm going to be using both here. Okay. So first, I already, we already ran this LM5. So if you call like LM5, summary LM5, all right, it should already load up, right? So we already ran this, but just in case, you come back to this a later time, and then I just keep this and redefine this LM5 here. Okay, so I already ran that, and what I need to do is I'm going to name the step AIC function as step LM. This can be any name again, but it's important to name it so that we can call the summary, the result of the step AIC later on. And step AIC is going to take LM5. This is the linear multiple linear regression model that has all the independent variables in our data set and predicting balance. And I specify that the direction is both. I'm trying to ask for the utilization of both forward and backward selection method. And then let's run this line. It added step LM data frame to me. You can see that you can reach out to residuals, coefficients, effects, rank, and fitted values. And then in the console, let's see what it gave us. It gave us the starting equation. We start with all 5. And let's see what it did. But it ended up with age, education, income, and wealth. Well, it actually dropped the home value. That's what we did, right? So we did it earlier, and Step actually did it for us. And it gave us the ultimate model like this, okay? So it gave us these error statistics. So these are almost in our table, but you can reach out to these coefficients from here to identify what the coefficients would be for these independent variables and intercept. Let's see if we can do it here. Let's go under summary, and then let's say step LM coefficients. Let's call them. You see that I do have my intercept, age, education, income, and wealth. I could use them to put together my linear function. Let's see what else we can get. The useful stuff. Yeah, fitted values. You can get the predicted values by calling this. You can get the residuals. I can get the ANOVA table, I believe. Let's see. Yeah, I do get my ANOVA table in a different format. This is not using p-value. It is using actually AIC. It's a different term, error term that step AIC function is using. Basically, it's telling me that it dropped the home value in the second iteration and it stopped there. Okay. All right, so as I said, the last thing that you could do is to check the VIF values that belongs to this final linear regression model. Let's check it out, VIF in step LM. And you see that I am getting still the same high VIF values, and your conclusion would be to drop income further, right? So step AIC, unfortunately, it gave me a pure, nice multiple linear regression model, but it doesn't check the VIF value. And what you need to do, you need to drop the income out of this equation. So your equation, actually we ran it earlier. This is the last one that we ran right over here. This is, I will copy the entire thing, LM7. So LM7 has only age, education, and wealth. If I drop income, and let's see one more time. I copy and paste them here and highlight this, and I hit comment and return. You can see that we already concluded that LM7 should be our last multiple linear regression result, because all significant level of regression significance is a pass here. All my independent variables are statistically significant because p-values are less than 0.05. And guess what? My VIF values are fine now, right? I can stop here, all right? So long story short, you can definitely utilize the AIC function, but at the very end, you should definitely check for multicollinearity.